We are seeking all three solutions to this cubic polynomial equation. We rewrite the cubic polynomial equation in the standard form. We can let p of x equal the cubic expression. We now use the factor theorem to search for a rational root. So we try the factors of negative 18. Let's try 2. P of 2 gives us negative 14. Let's try another factor. P of 3 gives us 0. A remainder of 0 tells us that x minus 3 is a factor of the given polynomial. Since x minus 3 is a factor, we divide p of x by 3 using synthetic division. So we write out the coefficients of p of x. We have 1, negative 1. The coefficient of x is 0. The constant term is negative 18. 1 plus nothing is 1. 3 times 1 is 3. Then we multiply. We add negative 3 and 3, that will give us 2. 3 times 2 will give us 6. 0 plus 6 is 6. 3 times 6 is 18. 18 plus 18 is 0. So this tells us that the other factor is a quadratic expression with a coefficient 1, 2, 6. This is the remainder of 0. The quotient will be x squared, 1x squared plus 2x plus 6x. You can rewrite p of x as x minus 3 times x squared plus 2x plus 6. When p of x equals 0, then we have x minus 3, x squared plus 2x plus 6 equals 0. The linear factor will give us x equals 3. For the quadratic factor, we can look for the root by applying the quadratic formula. So we now substitute and then we simplify. So we obtain x to be equal to negative 2 plus or minus square root of negative 20. Now we rewrite, recall that square root of negative 1 is equal to I by the definition of complex or imaginary numbers. Simplify our roots further to obtain x to be negative 1 plus or minus square root of 5i. Therefore, the solutions to x cubed minus x squared equal 18 are x equal 3, or x equal negative 1 plus 5i, or x equal negative 1 minus root 5i.